大家搞早，早上刚有困饱哎，你们很没有精神哦。大家早，欢迎来到 PyCon 台湾2024，今天是第2天的议程，我是今天的主题演讲的主持人 Connie。Good morning, everyone. Welcome to the PyCon Taiwan 2024. I'm the host, Connie, and nice to meet you here. 本届呢的大会是由钻石级的赞助商 Python 软体基金会赞助举办。The event is sponsored by Python Software Foundation at the Diamond level. 今天主题演讲者，他也是来自 PSF Python 软体基金会。他呢是我们第一个资安的常驻开发人员，而且致力于供应链的管理跟安全。The keynote speaker is the first security developer in residence at PSF. And he will focus on securing the supply chain and improving the security posture of CPython and the project in the Python packaging ecosystem. 他今天将讨论我们的软体供应链所面临的威胁，而我们呢为了保护 Python 这个生态圈的安全所做的一些努力，可以采取的步骤，还有可以确保我们的每一个人的安全。Today he will talk about the threats to the software supply chain, the effort and the steps we can take to keep the Python ecosystem safe for everyone. So let's welcome Seth Larson, Bytes, and people. Let's welcome him.
Thank you so much, everyone. It's really great to have you here. I have a talk today about stories, about communication, about how we can all collaborate together better to achieve better security outcomes for the Python ecosystem. So I want to start off with this QR code. So this QR code has a link to all of the slides, all of the resources that I'm going to talk about today. You don't have to, if you don't get it right now, it's totally fine. I also have it at the very end of the presentation, but if you want to get it now, totally fine. All of the links and references and everything are here. And I also blog about like Python, the internet, security, things that I care about, because I really love telling stories to people. I think storytelling is a really powerful tool that we can all take advantage of. So my primary interest when I joined software was not security. It was the internet. My very first experience with learning about software, that big spark was the internet. I remember when I was a kid and being able to connect with friends after we had to leave each other's houses to still play games, and how it was incredible that we could connect even though we were very long distances away. And so the web is just a really big part of what I think is cool about technology. And so the very first gigantic effort to secure the web was HTTPS, something that at this point we can see is at almost 100%, right? This is something that we almost take for granted these days because it's just ubiquitous now. But if you look, HTTPS was standardized quite a long time ago, in the 90s, around the same time that I actually joined the internet. And I wanted to provide some contrast to the very first keynote and potentially show how the internet sounded back then. Almost algorithmically generated, right? It's my favorite part. So that's enough of that. That is what the internet sounded like when HTTPS was first standardized and available. So that's back in the 90s. I kind of pegged it at 95 because there's a whole bunch of different dates. But you can see that earlier graph that we were looking at, the date stopped at 2016. And you can see this huge trajectory upwards, right, where HTTPS started becoming way more used. But it was available all of those years ago, so almost 30 years between now and then. And so what you can see from this graph is that the technology for security being available is not all that's needed. There has to be something else. So what was that something else for HTTPS that we saw this huge improvement? So in 2014, Google announced that it would start ranking pages that used HTTPS higher. And then in 2016, Let's Encrypt, this authority that would issue certificates for free, became way more popular. And so it was almost free to have an HTTPS website. And then in 2018, browsers started showing warnings and errors if people had websites that were accepting passwords or payments that did not use HTTPS. And so that was the something else that required HTTPS to start skyrocketing in usage, right? So the key point here is that this web is this huge, decentralized place, right? So like this graph, you see this graph, and this is about HTTPS, but what I see in this graph is there's millions and millions of people out there making decisions to adopt HTTPS. So this is really just a graph showing how many people are deciding to enable security at any one time. And so I also see a lot of opportunity in this graph, because this is kind of how I see software security right now, right? We have this huge gap where we haven't been focusing on security as much until recently. But now that we're starting to focus on it, what tools, what ways can we make that faster? How can we make it so that more people adopt it? And so I actually see a lot of opportunity in this graph. How can we replicate this elsewhere, not just for the web? So what does the web have to do with Python? Well, as I was introduced, I'm the security developer in residence at the Python Software Foundation. And I have my mission statement up there. This is kind of how I think about my role. It's to improve the security posture of Python, pip, and then the entire Python ecosystem. And in a way, the entire Python ecosystem is not too dissimilar from the web, right? We have all of these very decentralized and distributed and diverse communities that are all making decisions and working on things on their own. So on the Python package index alone, there's over 600,000 projects, and there's millions of Python programmers out there. And so how can I, as a single person, a single node in this huge graph of Python, this huge network, how can I make the biggest difference towards, okay. Sorry, y'all. How can I make the biggest difference towards security? And I think one of the ways that we can make the biggest difference is by telling stories, right? Because stories are really, really powerful tool, because you can hear a story from someone else, and then you've learned from their experience without having to go through that experience yourself. And it's also free, so it's information, right? It's really easy to spread and share. And I think the most critical part about stories is that you can remix them or adapt them for your certain situation. So if there was just one story about how to do a certain thing, that does not work in a decentralized system or a network like Python or like the web. There has to be more than one way. And because all of these different communities are different, right, and speak different languages, for example. Thank goodness I have AI to help me out here. So it's on all of us to hear these stories and then spread the ones that we think will be the most helpful. So this picture up here is me at Open Source Security Conference, which this conference is a conference about security folks. There's nothing to do with Python at all. Very few of them use Python in any way. And I was at this conference, and I was a part of a tabletop session, which is essentially a way to share stories with a whole bunch of people. We were all playing a different role. In this instance, I was playing the role of an open source maintainer whose project was getting exploited through a critical vulnerability. And all these other people were playing different roles, like an IT manager, a CISO, an application developer, someone who is a security developer, right? And hearing all of the stories, all of the different perspectives about how they were handling and how they were reacting in this way was really enlightening to me. And so I spend a lot of my time actually not talking to Python people and talking to security people so I can learn from them, remix the stories, and then share them with all of you. And I also think that a really big part of my work is filling in the gaps, so I have quite a bit more time than maintainers to try to fill the gaps between where there is something that's being required for security and where we are right now in the Python community. So filling those gaps makes it so that when it is time to actually, tell the stories, adopt these tools and practices, that it's as easy as possible, It's try to make it so that people don't have to do additional work. So when I was talking about, oh, there's no color. When I was talking about that opportunity, what I think that opportunity was, I believe it was something called a positive feedback loop. And so a positive feedback loop is essentially where if there's a system where there's two sets of individuals, entities, people, and they both want different things sometimes, but sometimes they want the same thing. And if that system is primed in a way that makes it so that if one side starts doing something, then the other side will want to do that same, like a different thing or the same thing. If those things actually align, then what you see is that exact graph network effect of massive adoption or a massive change in ecosystem because the incentives are aligned. So yeah, this relationship that we see here in the middle is the one that we're most used to, right? You have someone who's producing software, and then you have someone that's actually using software. But what other systems, what other relationships are there out there that we can take advantage of and use to make our users more secure and make our ecosystem more secure? And I also wanted to note that, especially for open source, the left side of the graph there, software producer side, there's way fewer people than there are users, as we know. Some of these projects get millions and millions of users, and there's only a handful of maintainers. So how can we use technology to protect the left side from burnout? I think that's a really important thing to keep in mind. So this talk is about open source security. I'm going to talk about why it's important, especially now. It's been important for a long time, but now it seems like we've been seeing lots of news cycles about it. I'm also going to talk about supporting a culture of security in Python with the tools and data and infrastructure that exists today. And I'm also going to talk about how everyone can take a part in this. You don't have to have the word security in your title. You don't have to be a security developer to make a difference for the security of the Python ecosystem. So I also wanted to note that I think that security gets kind of a bad rap. It gets a bad name, right? I would like it if security was more a topic that anyone felt like they could talk about. And I understand that security, from the outside, we get a bad brand because it can feel scary. It can feel like things need to be perfect, otherwise they're not right. It can feel adversarial, right? There's attackers and defenders here. Maybe you read scary news stories about security on PyPI or Python, and that can scare you away. I think that you don't have to be an expert to make a difference, and that these feelings of fear make people not want to engage with the community. I'm here to tell you that you totally can engage with the security community and learn these tools. So let's start with the prologue, talk about why open source security is important now. And because we're security nerds, we're going to go from chapter 0, index from 0, of course. So here's a graph about all attacks, all of the software attacks that exist. You can see the y-axis here is the number, like the amount of resources it takes for an attack to be successful, or to even attempt it. And then on the right side there, there's the value of the target. And this, hopefully we have color. Okay, we do have color, good. So in that top left corner, this is the boring corner, right? Because no one's really doing this. Why would you try to attack something, spend tons and tons of money and resources if it wasn't very valuable, right? So for the most part, this is the quadrant of boring. There's not a whole lot of attacks that happen here because the attackers would lose money, right? On the bottom here, this is where anyone who has been running a web server in the past few years understands this bottom corner. If you are connected to the internet, you are just constantly being attacked by essentially what is like scripts that are just trying every single IP address. You see the same thing with like phishing emails, right? They'll send an email out to everyone or a text out to everyone and just kind of cross their fingers and hope that 1 out of 1,000,000 people, they'll get them. And the reason why this works is because it is so cheap, right? It is extremely cheap to write a script and then just run it. And you might as well just keep running it forever. So this is why there's just tons and tons of attacks. I think the most interesting quadrant is the top right, where the amount of resources are really, really high, but then the value of the target is also really, really high, at least in the eyes of the person that's trying to do this attack, right? This quadrant is really interesting to me because it tells you a bit about what an attacker is interested in. What do they think is valuable, right? So whenever you start seeing attacks that are happening in that quadrant, you can know that this is something that they're at least experimenting with. Maybe it won't become this huge issue, but maybe it will. So let's line up some of the more recent high-profile attacks involving open source onto our quadrant, right? So the one that many people may have heard of is Log4j. There was a vulnerability which was extremely easy to exploit in this extremely common and prevalent Python or Java package, actually. And because it was so prevalent and so easy to exploit, it was almost immediately tons and tons of scripts were written that were just attempting to exploit this vulnerability in every possible way. And then next was in 2023, so this is after I joined the PSF, the libwebp vulnerability. Now this was an actively exploited vulnerability. This is how it was discovered. It wasn't discovered beforehand by someone who was willing to fix the issue. It was discovered because it was being exploited actively. This was a highly targeted attack. It was attacking iPhone technology, essentially, but it was exploiting a vulnerability in an open source component. And then finally, probably the most high-profile attack recently, XCUtils. This was an attempted backdoor of an open source project that spanned multiple years and was an extremely highly resourced attack. So if we line these attacks up on our graph, we can see Log4j there on the bottom. We don't really care about the value of the target. We're just going to attack everyone. But then the more interesting quadrant actually has libwebp and XCUtils. XCUtils being extremely high up because it was multiple years. And so this is giving you some intuition about what attackers are thinking about. They're seeing open source as a way to exploit potential later people that are using open source. And it turns out open source is used a lot. So 90% of commercial software projects across all industries include open source components, one or more. That's a big number. And you might be thinking like, that's just curl. Everyone uses curl, and so yeah, it just shows up a lot, right? But no, it's actually, if you count by lines of code, over 70% of lines of code in these commercial software products is open source. And so this is why attackers also know this. This is why attackers are starting to target open source projects and exploiting vulnerabilities in open source projects, because they see it as a way, a means to an end to be able to attack these companies, right? Or users. And this is something that we want to prevent, right? Even attackers will always be around, but we want to dissuade them from trying to use open source, because that hurts everyone, including scientists. It just hurts everyone to have open source be exploited this way. So it's something that we'd like to avoid if we could. And so yeah, these numbers basically tell a completely different story. Why is open source security important for all software? So governments have definitely taken notice of this. These are a few documents. I have to actually start off and say that I am not a lawyer. The one on the right there is a legal document. It is law, so please consult a lawyer. This talk does not is not legal advice. But these two documents, one is from the White House, the executive order, which essentially, an executive order is a message to all federal offices to say, hey, I want you to do something. And what this message said is, I want all the software that we buy to be secure according to these specifications, and I want you to figure out what that means. And so the reason why they did it this way is because the US federal government is one of the biggest buyers of software in the entire world. And so having that knock-on effect of, you have to develop the software that we buy securely, it tries to have this network effect, right, where you're trying to boost things to the next stage. And then the EU Cyber Resilience Act, it goes even further. It requires all software in the EU to be secure. So the themes of this document is that users expect their software to be secure. They're not likely to ask for security. They kind of expect it to be there. And that makes sense to me, because when I'm interacting with infrastructure like bridges and roads, I don't expect them to be safe. I don't think about that actively, but I expect it, right? And it also highlighted that software security is a systemic problem. It's not just one person's fault or one entity's fault. It's everyone that needs to do their part, not just open source and not just manufacturers, everyone. So the real question here is, how can we speed it up? We don't want it to take 30 years, right? We'd like it to be faster than that. So the first chapter is, what is software made of? It seems like a really easy question, right? But actually measuring software is super hard. If you were asked this question, you'd probably answer with, oh, like, what software is on my machine? Maybe Slack, I guess, maybe a browser. But you need to be able to be way more specific than that. So when you start asking about all these things, it becomes a way harder question to answer, right? How do I tell a computer that I copy-pasted my entire project from Stack Overflow? That's a tough thing to do. So the attempt to do this, to describe software to software, is called a software bill of materials, and otherwise known as SBOM, pronounced SBOM, because that's a mouthful, right? Hopefully the AI can handle that. And so this is basically like a nutrition facts or a list of ingredients for software. And the reason why these are super important is because they're directly referenced by the White House Executive Order and by the EU. So we know that these are going to be important in the future. So anyone who's familiar with XKCD already saw this coming. There's two standards for SBOMs, but they both carry the exact same information. So don't worry too much about which one to pick. Just pick one of them and use it. And if I'm successful, most Python packages won't have to worry about this at all. So what is a vulnerability? The primary use for software bill of materials is to track vulnerabilities in your software. And so a vulnerability is something that affects one of these three things, either confidentiality, integrity, or availability. And so I used, because I was probably hungry at the time, I used like delivery, like food delivery metaphors for here. So either confidentiality, open a box to see what's inside. Integrity is you change the contents of the box, so maybe swap out something without the person noticing. And then availability is if you would like throw the delivery box away, that person that wanted the food didn't actually get it, right? So a vulnerability impacts one of these three things for software. And how do we describe vulnerabilities to machines? We use a lot of different systems. One of them is CVE. And so they have these, basically, which are just identifiers that help you talk about vulnerabilities as a human. But then on the other side, there's a machine-readable format that they can use to tell you whether or not the software that you're using is affected. So CVE has been around for a really long time. Python Software Foundation and other open source ecosystems and projects are starting to get involved with CVE. So if you have any questions or you want to join yourself or anything like that, like there are friendly faces out there right now. It's not just companies. There's also open source projects too. So Python itself already provides SBOMs. This is something that I finished like earlier this year. And they're available in the SPDX format, and they've been available for new ones. So you don't have to even generate your own for Python. Let's give this one a spin. So if I'm on the python.org/downloads page, and I'm going to download the source code of Python. And I'm also going to download the SBOM file. And let's take a look at it, right? So that's obvious. We see CPython. We knew that already. There's CPython in here. But what else is there? There's also these direct dependencies of CPython. These are probably projects that you've never heard of. And oh, the ghost is very hard to see. There's supposed to be a ghost in the top right. Endor Labs actually coined the term phantom dependencies, which is essentially dependencies of software that you didn't even know was a part of it, right? So you know you're using Python, but you don't know that you're using MP-decimal. And as given away by the space on the bottom of the screen, there's even more than that. So pip is also included in Python, and pip itself has, I think that's 18 different dependencies. So there's a lot of software inside of Python. So now let's scan our SBOM to see what happens, what falls out. So these are a few different options. Pip audit is for like pure Python. If you just have a bunch of Python packages, pip audit will work great. But then there's other options for supporting like all the different ecosystems. So CPython is written in C, so we're going to use gripe. So here's some code. It doesn't matter too much what it is, but there's our SBOM document up there. And we run it, and we see all of these vulnerabilities. Huh, that's interesting. Let's see how those look. So you can see the slightly yellow. The colors are not coming through great, but yeah. It's in CPython, libexpat, and urlib3. So there's vulnerabilities affecting our software that's not even just CPython. It's in those phantom dependencies. So let's pick one out in particular. That one on the bottom is really, I feel like I remember that one because I actually fixed that one. That's a project that I maintain. So let's dig deeper. Who introduced that vulnerability to that code? So this is a lesson that there's no shame in CVEs. CVEs are a positive indicator of security. If your project is able to fix security vulnerabilities, that is a really good thing. That's something that you want in a project, for an open source project, right? You don't want, if there's a security issue found, that it just never gets fixed. You want people to fix the issues. And so in particular, I would really like maintainers to not stress about the process. Just fix the issue, make it available, and then publish the CVE. Don't stress about it. Something for users to ask is, are you getting security fixes? So CPython has a policy of providing 5 years of security fixes. But other projects have different policies, and so you have to know if you're using a supported version, a version that's not end of life. So because SBOM documents are referenced directly by the EU and the White House, I really expect that there's going to be a huge demand for SBOMs. So even if you're just starting to learn about them now, that's totally fine. But I think that in a few years' time, this will be a very common thing to talk about and ask about. So because of that, I'm trying to get ahead of the curve and say we need to have a comprehensive SBOM strategy for Python packages. And being able to track those phantom dependencies is a really, really hard problem and something that we need to solve because they affect the software security just as much as the top level one that you actually know about. And a really critical part of this work is trying to minimize that burden on open source maintainers. I don't want everyone to have to do what Python did, which is to write one by hand, basically. I want it to work automatically with tools so that users don't even need to come to their open source maintainers projects and say, hey, I need an SBOM. If that starts happening a lot, that means that I've failed, right? Because I want to minimize that burden. So here's some things, and this will be included in that document that I had the QR code, just some bullet points of some potential ideas on how you, even someone who is not a security developer, just someone who writes code, is an application developer, can build a culture of security in Python. So adopting lightweight security policy, using a vulnerability scanner, trying to fix CVEs, and most of the time you just need to upgrade your software and to generate SBOMs instead of asking maintainers for them. So chapter 2 is all about software in motion. So the internet is capable of sending data across a wire, right? And the really cool thing, the interesting part about the internet is that the middle bits don't need to know very much about each other. It's all about just sending the data along to its destination. And by default, these systems don't have security built in, right? And so if you inject some data into the middle, it just gets accepted by the end because there's no way for anyone else to tell whether data got injected. This is how the internet works by default. This is how TCP works. So this is why we use HTTPS, right? It turns this network that is untrusted into one that we can trust. By able to see when data is coming across the wire, we will know if the original server was the one that sent that data. And so that's really important. And the way that it works is basically if someone tries to inject data, we just throw an error. We say someone messed with the stream, right? So there's not really a guarantee that you're going to get perfect data on the other side, but we do throw an error when something bad happens. And this seems to be enough to really discourage a lot of bad actors from trying to do this. And so can we do the same for software, right? Software is very similar to data on the internet. Software is data, and it's going from place to place, right? It starts maybe in a source code repo like GitHub. It gets built, it gets published to PyPI, and then eventually someone installs it. So that data is flowing and taking different forms as it's crossing all these different boundaries. So how can we do that for software? Well, the thing to notice is to see where the places where it's fragile. It seems to be those hopping points where they're hopping between the different places, right? So when it's at rest, software is limited to whatever vulnerabilities are in that software, right? So if you're an attacker and the software is, on GitHub, you can't change it, right? And so all you have is whatever is already there in the source code. But when it's changing hands and moving, that's an opportunity to put bad code into it, like we did with TLS and HTTPS, right? So they'll try to do that at every single turn. And so these are some examples of places where that will happen and where it happens today. If you're adding a new dependency, trying to install something new from PyPI, when you're deploying software from one machine to another, or when you're getting data or software from the internet. So we'll start with adding a new dependency. So this one is actually, for the most part, attacking a human being, right? It's trying to get in the way and cloud your decision making to make you accept a bad dependency. And so the ways that they do this is they fake data. They put data that looks trustworthy onto PyPI or Conda or wherever you're trying to find a software package from. And so things like the number of stars, or how much is it downloaded, or how many people have favorited it, or what links do we use, or what is the name of the software project. These are all things that attackers can control directly. And so they'll use every single one of them to try to make you install the package. And I think that there's a really critical point here that pip install means that you're running code. So you need to make this decision before you run pip install, because if you make the decision after the fact, it's already too late. A lot of times what people will do is they will try to make their software package feel like the solution to your problem. So on Stack Overflow or on GitHub, they will just post, oh, I solved the problem this way, pip install this. So don't just copy paste that in. You need to make a decision about whether that project is good. And how do you make that decision? Using data that is verifiable, that's stuff that you cannot fake, this is the most effective way to keep yourself safe. So you can ask yourself these questions, like how long has that project been around? Do we already use that project? Do we know the people that maintain this project? How many projects depend on this project? These are all things that, as an attacker, it's really hard or impossible to fake. And so if your policy is based on this, then you're going to be a lot more safe. So here's some resources that I link about places where you can get free data about open source projects, especially for security decisions. So what about that first hop, right? Locking dependencies. What is that? So locking, let's say you order something online and you love it. It's so great. But then you run out, and so you want to order it again. And so you order it again, and it's great, and then you run out. But then you order it the next time, and when it comes, there's something else in the box, and that's not what you ordered. So locking prevents that. Locking means that every single time you order that thing, you're guaranteed to get the same thing. So that property is really important to have for software, right? We want consistency. We want, whenever we run a command, whenever we do something, we want it to be the same every single time. We don't want something new. We don't want potentially things to break. And so that's really good for security and for development, right? We want to use these. So these are some tools that you can use that allow you to lock dependencies. So pip tools, Poetry, PDM, and UV. And it's really important to use these for when you're developing applications or when you have like a build and release process, because those processes, you want them to be secure no matter what. You don't want them to change over time. So the next hop there is between PyPI and the build process. So this is where trusted publishers come in. So trusted publishers is a new security technology for publishing to PyPI without a password or an API token. And the reason why these are so important is it makes it almost super easy to publish to PyPI. You don't have to manage a password or an API token. And so for this reason, users actually really love this. And so the security part of this is important, but it's also a usability, a developer experience fix, right? And so over 17,000 projects have adopted trusted publishers since then, just because it is way easier to use. And so this is getting towards tools that don't exist fully yet, right? So this is like, where in the future can we go? So this provenance is being able to tie the origin of software back to even further. So can we tie it back to the build process? Can we tie it back to the source code? And by doing this, it makes a really interesting thing by making it so that you don't have to trust the middle. Just like with HTTPS, right? Data is flowing through this system, but you don't have to trust any of the middle steps. So in this case, build provenance makes it so that you don't have to trust PyPI, which is really great, because if someone were to try to attack PyPI, then it would be totally fine, because you don't have to trust PyPI. And so reducing the number of entities that you trust is really important. So let's see it in action for CPython. CPython uses this technology called SigStore. This is one of the most exciting new technologies for software security, because what it does is it essentially provides what HTTPS and certificates are for software. And so let's try using it with CPython again. We're back on the downloads page, and we have SigStore files right here. So we're downloading the source code again, and we're going to download SigStore. There's SigStore bundle there. And then we're going to try to verify it. So what identity do we want to use? What's that end identity that we know the software is coming from? So in Python, we have this concept called a release manager. That's Thomas. Hi, Thomas. So this is how we represent Thomas to a machine. It's just his email address. And so what we can do is we can take the file that we downloaded, and we can take this bundle from SigStore, and then we can run this command, and it'll see whether the software came from Thomas. So we run it, and it says, yes, the file is from Thomas. That's great, because now we don't need to trust python.org even. Like if python.org started serving up bad stuff for whatever reason, maybe an attacker, we would know that we're safe, because we know that it came from Thomas, and we trust Thomas. So this is really, really interesting property of build provenance, right? It makes it so that you don't have to trust all these steps in the middle. Even if someone were to hand you, like send you a file and say, oh, this is Python, like you could do this. It doesn't matter where it comes from. So that's the really interesting property of provenance. So I really encourage everyone to subscribe to this blog. PyPI has a new blog. This is like past year and a half, very new thing. And a lot of the stuff that we talk about is security related on PyPI. Things like new features, ways that we're thwarting malware. So my counterpart, Mike Fiedler, the PyPI safety and security engineer, he will write a ton on this. And so this, if you're trying to look for like new security features, new features of PyPI, this is a great place to get that information from. So if you're trying to make software, when you're trying to use software more secure, these are some options you can do. Maintainers, the number one thing, use trusted publishers. There's so much that it is a really, really great system. It's way more secure, and we're actually building even more security features on top of trusted publishers. So if you adopt it, you'll just automatically get those new security features for free. And as a user, and everyone actually involved, creating a really great policy for using open source software with verifiable data will keep you safe from a lot of the attacks that are really common today, where they're trying to trick people into using bad software. Using lock files to make sure that things are consistent, and of course, following the PyPI blog. Okay, last story, software as a story. That's what SaaS stands for, right? So this is a story that I told at a lightning talk at PyCon US, I believe 2023. Let's say you're trying to install a Python package. This is just another normal day in Python land. And then you get this error. Has anyone seen this error? Hands up if you've seen this error. I've seen this error a bunch. It's really common if you're on like Windows or Mac OS. Like, it's kind of annoying. So it's just not a great error, right? Like, what does that even mean? I guess let's solve the problem together. I would probably just put it into Google or Stack Overflow or something, right? Let's do it. Let's see what happens. Okay, Stack Overflow first. Okay, I'm pip installing. I got this error. Okay, I got an answer from 10 years ago. It's got a lot of upvotes, millions of views. It says use trusted host. Now what does use trusted host do? Well, it turns off security. So that's not good. It makes it so that HTTPS is no longer verified. And so now whenever I'm pulling from PyPI, there's a chance that attackers can just inject different software into my network, and then it just gets used automatically. That doesn't seem great. So there's actually another answer in that same exact thread that's telling me to add trusted host to my configuration file. So that's really bad, because now, even if pip were to fix the issue, security is still off. And it's 10 years ago, 10 years, millions and millions of views. How many insecure configurations are out there? Probably more than a few. So let's ask ChatGPT. AI will solve the problem, right? Okay, ChatGPT, this is real. I did this. Pip install, I'm getting this error, what do I do? So ChatGPT does actually a little bit better than Stack Overflow. It tells me, okay, maybe manually install the certificates. I'm like, I don't know what certificates I need. I can't do that. And like, where do I install them? I don't know. Upgrade certify. Okay, I can try to upgrade certify, but I can't even run pip install right now. So I don't know how I'm going to do that. Upgrade pip. Well, that's kind of the same problem, right? I can't run pip install. What do? I need help. Okay, use trusted host. And we're back to where we were, right? At least with ChatGPT, I will say, it did say that using trusted hosts is an insecure thing, but if it's the only thing that works, it's probably what you're going to do, right? And that's, in my mind, that's a problem. If the only thing that is going to work is insecure, that's not the right approach. So that was the correct answer. The correct answer was to upgrade pip. But the thing is, if pip is not working, you can't upgrade pip. And that's a real problem. So I knew about this issue, and many other people. I'm not the first one to discover this. This issue has been around for a really, really long time, and it's no one's fault in particular. It's just software and all these decisions that were made a really, really long time ago. And so I made this tweet, and it was probably my most popular tweet that I've ever made. It got a lot of traction online about this new system, this ability to use your system certificates that would actually solve the problem. The reason why you're seeing this issue is because maybe your IT admin or someone is putting custom certificates in your certificate store and pip is not using it. So the real thing to do is to upgrade pip and get this new feature, but we weren't getting any feedback from users after we implemented this feature. We created it in pip and we tried to tell everyone about it. Hey, please test this because we don't have this problem, but we know that lots of people are having this problem. Please test it and tell us if it works. And we didn't get a lot of feedback. And it makes it really, really hard to break something potentially, putting this new feature, because we didn't know if it was just going to suddenly break millions of people. So we have a lot of tech debt at the ecosystem scale. We're adding security after the fact. This is going to be this is the hardest part of all of this, right? Is where things need to change. Because old information is really, really popular. How do we help people? And user feedback is really rare. So one mechanism that we can use is Bandit. So this is a software analysis tool which will tell you if the code that you have written is using an insecure feature. And so if people adopt this and start taking action as a result of the things that they're seeing from this tool, that will be really great because your code will be more secure, but then also maintainers will know that you're using it and be more willing to actually contribute to Bandit itself. Testing with warnings. So warnings are another mechanism that maintainers can try to use to get users to take an action, right? Try to say like, oh, this feature is going away. You get an early notice. And so testing with warnings is really important. Also keeping conversations going, right? Like make sure that your users know where to find you. So if you create like a new warning or you create a new error, put a URL in there because then users can follow it and then tell you like what they're experiencing. And so users, it's on you to also try to make sure that maintainers know what things you're experiencing because then it makes it easier to develop the software. And the last thing is that breaking changes, it's something that no one wants to do. It's almost always a last resort. It's going to be hard, but you have to try to accept them with grace and be collaborative instead of, I know it's difficult when something breaks your workflow, but the best thing to do in that situation is to describe how your use case is not being fulfilled by this breaking change. And maintainers, I would like it if it's good to just document these as soon as possible and try to get the word out. So as soon as you decide that things are going to happen, just put a warning in there. And if it really goes bad, you can always yank a release to roll back and try again. Okay, so the next story is for you all to tell. Let's secure Python together. So what can you do? There's tons of local Python communities. The thing I hope that you do after this talk is to learn more and to share and to adapt the stories for the communities that you really care about and to take action because people see action. The nice thing about open source is all the work happens in public, right? So if you take action, people will see it and people will know that this is something that we do now. So these are basically like the basic things that you can do. The one on the bottom is the one I want to highlight. Security is a really important topic, and if you have like a larger security project for an open source project, try applying for funding. It does work sometimes, and it means that you can work on it a lot more and you don't have to burn out in your volunteer time. One I wanted to highlight is this securing the release process, which the scientific Python community basically tapped my shoulder and said, hey, Seth, we need some help with this. And we put together this really great document on how scientific packages, people that are not security developers, can adopt these features. And the most important thing for users of open source projects is to create a policy that lets you use software securely, but also contributes back to those open source projects. Because at the end of the day, an ecosystem that is based on trust can only work if trustworthy people can continue contributing. This is a picture of all the people that decide the direction of Python, core developers. And so it's really important that people that are trustworthy continue to contribute in our ecosystem. So anything that you can do about that, hiring maintainers, contributing yourself, contributing feedback, documentation, it all helps. And that's all I have for you. Let's go secure Python together.
They say thank you to this amazing, informative, and valuable speech. Thank you so much. So right now, let's move to our QA time. And we receive so many questions. The first question is about, in addition to the pipe audit, is there any other Python-based auditing tools?
Yeah, so Bandit is a really great one because so pip audit, there's so many tools that do vulnerabilities, right? There's also, Bandit. There's ones that do more than Python 2, so like CodeQL is a really good one. SemGrep is a really good one. And these are all tools that you run it on your code, and it'll tell you whether or not you're using something insecurely or if there's something that you should be using instead.
Okay, good. And next question, we would like to answer. As engineers, we know the maintaining is a multi-users packaging long time is challenging. How do you stay motivated for updates?
Yeah, so it feels like everyone has really covered this topic, which is the way to stay motivated is to contribute to a project that is meaningful to you. And so I really derive a lot of passion and motivation from internet technology. And that's why I only contribute to Python projects that do internet technology, so urlib3 and requests, right? So that's how I stay motivated. It's just really interesting technology to me. It's a really interesting topic. And so, and I derive a lot of joy from trying to solve these problems, right? Because these are not easy problems to solve. It never really is an easy problem. And so being able to navigate that and then solve the problem, do it in public, and then share afterwards, that is really motivating to me.
Thank you. And next question would be, what do you think about the XZ Newty backdoor?
Yeah, I think the most intriguing thing about the XCUtils backdoor is that because it happened to open source, an open source project, immediately after it was public that this had happened, all of the security experts online were able to go in and look at all of the source code, all of the history, what had happened, and we knew within 24 to 48 hours almost everything that we know today about the XCUtils backdoor. And how that contrasts with closed source or proprietary technology, right? If an attack happens to a proprietary technology, it's almost, the company is the only one that can really do anything about it, whereas with open source, we're able to actually all collaborate and keep each other safe and not just rely on a single entity to do the work.
Ooh. So let's move to the next question. It's from Kaza. Do you think Python beginners should learn how to add certifications to layer projects from the start?
Yeah, I think this is a two-pronged answer here. So on the first side, I think that if beginners need to think about security in that sort of technical depth when they're just starting off, then the people that are developing the software to be used have failed, right? Beginners should not need to think about certificates. Beginners should be it should be almost automatic or really, really easy to do. You shouldn't need to know how HTTPS works low level for things to work and for things to be successful as a beginner. As you become more experienced, I think it's important to start learning little bits about the technologies, obviously, because being multifaceted is really an important skill. But beginners, let's protect the beginners. Let's try to keep Python an easy-to-use language. And I think it's the responsibility of people that are developing the software.
Thank you. Next question. If I want to create a popular package, no, I want this also already. Let me change.
I can answer that one too.
Yes, I think the first one.
Yeah. Okay, yeah, if you want to create a popular package with tons of users, what would you do? I think I wouldn't try to create a new package first. I think what I would do is I would contribute to a package that already has tons and tons of users and stars, because I know for a fact that that problem that that package or project is solving is important, right? If there are tons of people using it, it means that it's solving an important problem. I think that that would probably be the approach that I would take. If you are going to try to create a brand new project, I would first try to identify a problem or something that is not being served properly in the Python community yet. And so doing it for yourself is the most important thing. If you have a problem in your life and you think that it can be solved by technology and there's no projects out there that are doing it the way that you want, then start a project that way, because maybe there'll be other people that have that same problem, and then that's a reason why projects take off in popularity.
Okay, that's interesting. And next one is Kaza. Will SIG stores become a primary project promoted by PSF?
Yeah, SigStore and the technology behind it especially are extremely important for supply chain security. We already use SigStore for CPython. I can see us using SigStore or the backing technology for almost all Python packages. It is a really, really great technology. I can see it being a really bright future for not just the PSF, but all open source communities using this technology.
Wow. Okay, next question is very interesting. Some tech giants reduce the investment in open source projects and ups to hire talent in lower cost region. What are the consequences of the trend for OSS?
Yeah, so the really hard thing about this is that continuity is something that's really important, because trust is not something that just happens immediately, right? You would love it to work that way, but it doesn't. So the people that you trust the most in an ecosystem, if they're suddenly not able to do work, then it is not a great outcome. So I think that trying to maintain continuity while expanding into all these other regions is the most important. That's probably the best way to do it. Keep the continuity, keep these trusted individuals in the ecosystem.
Wow. And next one is from Kevin. How far do you think we have come in terms of security in general since the later Kevin's words? Anything special on Python you can point to?
I am not familiar with Kevin's work, so I don't know if I can answer this question. Sorry, Kevin.
That's fine. Let's move to the next question. Okay, it's not a question, it's just a comment. When science shows that you introduce the bug, debugging is like a mystery no more. When you are both the detective and the murderer.
I can only agree. There's so many times where you run, there's an issue, and then you run git blame, and you're like, oh, who did this? And then it's you, and you're like, okay. I'll stop looking.
I will help you. I will help you. I'll become your security.
That's when you run away.
Okay, let's move to the next question. What are you working on next?
Yeah, so through the end of the year, I'm going to be working on the strategy for software bill of materials for Python packages. I think that is the place where I can have the most impact working on this full time, because there's just so much information, and because it is going to be required by law in the EU, it is both really, really important, and I can see that there's tons and tons of gaps, and I can see that it's going to be really important for open source, and I don't want every open source project and maintainer to try to have to fix this problem on their own. Let's fix it once in a really great way, see how the community responds, if it's positive, and then move forward, fix the gaps, fix the problems, and hopefully most of the work can be saved.
Yeah, and let's move to the next question. Would you suggest every Python package maintainer adopt SigStore?
So you can. What I would recommend you do instead, and this is because I've been working with William Woodruff from Trail of Bits, a really great partner for the Python community. I've been working with him on some technology related to trusted publishers, which integrates the same technology as SigStore automatically. So instead of adopting SigStore, I would recommend you adopt trusted publishers, and then you'll automatically get all the benefits of SigStore from using trusted publishers. That would be my recommendation.
Thank you. And the next one, is there a way to reduce the friction in participating in testing and validations. For example, by providing a sample sandbox, volunteers can easily assistance.
Yeah, so if it's hard for you to get started in an open source project, to either contribute code or contribute documentation in any way, if it's hard to contribute, that's a bug on the actual project side. So there should be a really clear guide about how to get started as a beginner for your project, especially if this is a project that's expecting a lot of beginners. So like things that are really popular in the community, they should be really easy to get started. And so maybe if you're someone new coming to a project, it'd be great if you could use that newness, that new experience, to write down all the problems that you experienced, create an issue on that, and then the maintainers will have something to use to work with to make that getting started experience easier for you and the next person, right?
Thank you. I think we have no question from Slido right now. Oh, okay, there's no question right now. So we are open to have a question, to answer a question from our audience right now. And anyone want to ask a question? Please raise your hand and we'll bring our microphone to you. That's already answered about 14 questions. So I believe if you have more, you can ask question right now. You can grab it as a chance. 大家可以把握机会问问题哦，这次难得在这里。Don't be so shy. Whoa.
Do you have any insights? Like, this is not a question for you specifically, to be honest. Do you have any insights like the PSF is expanding on the like security employees and things like that?
Yeah, so the question was whether the PSF is going to expand its security developer program. I actually don't know. I think Mike and so Mike Fiedler is the PyPI safety and security engineer, and then there's me doing security. I mean, obviously, we would love to have more security engineers, right? It's not like there's a gap in the amount of work that needs to get done. It's definitely a problem of funding. So the Python Software Foundation is a nonprofit. We can only operate and do work based on people sponsoring us. So I want to take a second to thank Alpha Omega, which is the sponsor for my role. I really appreciate them. They've been a great partner to work with, and they've been really consistent. So they've been paying for my role for the past year and a half. And yeah, really thankful to them. So if your company really cares about security and wants to make sure that that work goes to the Python community and is really effective at the biggest scale possible, get in contact with the PSF. We're totally willing to talk with you and make it happen.
Thank you. Right now, so we have a few minutes. We can have one question right now. So raise your hand. 现在还有个机会，我们可以再回答一个问题，但只能再问一个问题。欢迎大家举手发问。如果5、4。如果我比较害羞的话，没有关系哦。等一下，我们这次会到后门那边跟大家一起聊一聊，所以呢还有点机会。Seth can answer your question at the battle later. This battle, not another battle. So, well, you got my joke. Okay, I got my joke. You're good.
Wow,
You're good.
I love it.
你们都没有 get 到 ，OK？ So just as when you at the battle to answer your question. So if you want, you can come later. And don't worry, in the afternoon, our keynote speaker, Zaz and George, will have a speech, and it will be at about 3:40 in the same room. So see you later. And let's thank again Zaz's amazing talk. He brings us so many information for us. So thank you, Zaz, again.